Hello, friends. Someone told you this morning that you were talking in your sleep. You don't remember a word of it. But somewhere in the night, your voice was working, forming words, responding, arguing maybe, or whispering something you'll never know. Your brain was speaking a language you weren't invited to hear. What most people don't realize is that sleep talking isn't random noise. It follows the grammar of waking speech. It pauses where pauses belong. It answers questions that weren't asked out loud. The brain that was supposed to be resting was, in some part, still running the conversation. What is your brain actually doing when it speaks words you never consciously chose? Welcome to Sleepy Mind Science. The answer isn't simple, but it begins in the moment sleep and wakefulness stop being opposites and start overlapping in ways neuroscience is only beginning to map. Breathe slowly now. Let your body settle into wherever you are. The night is quiet, and there is nothing to solve. Just listen. And now we begin. Sleep talking, known clinically as somniloquy, is classified as a parasomnia, a category of sleep behaviors that occur in the boundary zone between sleeping and waking. What makes somniloquy distinct from other parasomnias is that it doesn't require movement, arousal, or any obvious distress. The brain simply continues producing speech, sometimes coherent, sometimes fragmented, while the body remains in sleep. Researchers estimate that roughly 2 out of every 3 people have experienced at least one episode of sleep talking in their lifetime, making it one of the most common, unusual behaviors that the sleeping brain produces. The question this video follows is already present in that number. What is still running? When you think everything has stopped. Sleep talking can occur in any stage of sleep, both during non-REM and REM phases. But the quality of the speech tends to differ depending on which stage produces it. During lighter NREM sleep, stages 1 and 2, speech is often intelligible, grammatically complete, and even contextually appropriate, as if the brain is still operating within normal conversational rules. During deeper NREM, speech tends to become murkier, more fragmented. During REM sleep, the stage most associated with vivid dreaming, speech can become more emotionally charged, louder, and occasionally more distressed. The same voice, the same brain, but producing very different kinds of language depending on how deep below waking it currently is. The most comprehensive linguistic study of sleep talking was published in the journal Sleep in 2017, analyzing nearly 900 episodes recorded in a laboratory setting. What researchers found challenged popular assumptions. Rather than random babbling, the speech followed standard syntactic rules. It included pauses at grammatically expected points. It contained turn-taking patterns, as if the sleeper was waiting for a response from someone else. The most commonly spoken word across all recordings was not a noun or a topic. It was the word no, followed closely by negations, objections, and refusals. The sleeping brain, when it speaks, appears to be in conflict more often than it is at peace. The mechanism behind sleep talking in NREM sleep involves a phenomenon neuroscientists call state dissociation, a condition in which the brain does not fully commit to either sleep or wakefulness, but instead occupies both simultaneously in different regions. During state dissociation, the motor cortex and the speech production areas, particularly Broca's area in the left hemisphere, can remain partially active even as the rest of the brain descends into sleep. This creates the neurological conditions under which speech is possible. Without awareness, the machinery for language stays on, while the monitoring system that would normally register the sound of your own voice stays off. Sleep talking in REM sleep follows a different mechanism. During normal REM sleep, the body enters a state called REM atonia, a temporary muscular paralysis that prevents the sleeper from physically acting out their dreams. The vocal cords are also subject to this suppression, which is why most REM sleep passes silently. But when the suppression is incomplete, when the signal from the brain stem that enforces atonia doesn't fully reach the larynx, the words that are being generated inside the dream can break through. Researchers call this motor breakthrough of dream speech. The mouth and vocal cords briefly get switched on, and the sleeper speaks the lines their dreaming self was already saying. A neurologist at Mass General Brigham, Dr. Milena Pavlova, has described the core of sleep talking. This way you are asleep, but part of your brain hasn't quite transitioned to sleep mode. It keeps doing things that normally happen during wakefulness, including generating language. This description fits the current model of sleep as something that doesn't descend uniformly across the whole brain at once. Sleep is not a single switch that flips off. It is a rolling process, a gradient, in which different regions arrive at different depths at different times. Sleep talking is one of the signs that the gradient is uneven, that language is still awake even when consciousness has gone. Children talk in their sleep significantly more often than adults. Studies suggest that around half of all children between the ages of 3 and 10 experience sleep talking, at least occasionally, while only about 5% of adults sleep talk regularly. The developmental explanation relates to the maturity of the thalamocortical circuits, the neural pathways that regulate the transition between sleep stages. In young children, these circuits are still developing, which means the handoff between wakefulness and sleep is less clean, less complete. The boundary leaks more. As the brain matures and the circuits become more efficient, the transition becomes smoother, and the leakage, including sleep talking, decreases. Stress is one of the most reliably documented triggers for sleep talking in adults. When the brain carries significant unresolved emotional load, unfinished conflict, persistent anxiety, elevated cortisol from chronic stress, it has more active material to process during sleep. The prefrontal cortex, which governs executive function and emotional regulation during wakefulness, reduces its activity sharply during sleep. This reduction is part of what allows the deeper processing of the day's emotional content to happen. But when the load is too high, some of that processing can surface as vocalization, the brain working through conflict in the only language it has, even when no one is listening. Sleep deprivation dramatically increases the likelihood of sleep talking. When the body is overtired, the brain's ability to regulate its own sleep stages becomes compromised. The normal architecture of a sleep night, the carefully sequenced cycling through NREM stages 1 through 3 and then REM, begins to break down. Transitions become less orderly. Arousal thresholds lower. The brain oscillates more between states rather than moving through them cleanly. In this disrupted landscape, the conditions for state dissociation become more frequent, and with them, the conditions for speech. Sleep talking in someone who is chronically sleep deprived is often not a coincidence. It is one of the measurable signs that the sleep system is under strain. genetics plays a meaningful role in sleep talking. Twin studies have found that sleep talking co-occurs more frequently in identical twins than in fraternal twins, suggesting a heritable component to the tendency. The same genetic predispositions that increase the likelihood of sleep talking also appear to increase the likelihood of sleepwalking, teeth grinding, and nightmares. A cluster of parasomnias that share underlying circuitry. This suggests that what is being inherited is not sleep talking specifically, but a broader characteristic of how the brain manages its transitions between states, a trait that expresses itself differently depending on the individual. But that traces back to the same architecture. The voice that spoke in the night may have been speaking in your family for generations. Alcohol significantly disrupts normal sleep architecture in ways that increase parasomnia activity, including sleep talking. While alcohol is sedating and does help people fall asleep faster, it suppresses REM sleep in the first half of the night and then triggers a REM rebound in the second half. A surge of more intense REM activity as the brain compensates for what it missed. This rebound REM tends to be more fragmented, more arousal-prone, and more associated with vivid or emotionally charged dreaming. It is in this rebound window, roughly between 3 and 5 in the morning after drinking, that sleep talking most commonly occurs in those who consumed alcohol the night before. Fever is another well-documented trigger. When the body is fighting an infection, core temperature rises and the brain's normal thermoregulatory systems are disrupted. Sleep architecture during a fever becomes more fragmented, with more frequent brief arousals, shallower overall depth, and more transitions between stages. Febrile sleep is also characterized by more vivid and sometimes disturbing dream content, likely a reflection of the immune system's signaling molecules, cytokines, influencing brain activity. In this altered state, sleep talking becomes more likely. Parents of young children often notice this correlation without knowing the mechanism. A sick child talks more in their sleep than a healthy one. REM sleep behavior disorder, or RBD, is a condition in which REM atonia fails entirely, not just partially. In RBD, the brainstem's signal that should paralyze the muscles during REM sleep doesn't work correctly, allowing the sleeper to physically act out their dreams punching, kicking, shouting, running. Sleep talking in RBD is different in character from ordinary somniloquy. Louder, more distressed, more violent in content, and it is clinically significant. Research has established a strong link between RBD and the later development of neurodegenerative diseases, particularly Parkinson's disease and Lewy body dementia, making it one of the earliest detectable signs of a class of conditions that may not become fully visible for years or even decades. Post-traumatic stress disorder, or PTSD, is associated with a significantly elevated rate of sleep talking. The connection lies in how PTSD disrupts the normal memory consolidation function of sleep. In a healthy sleep cycle, the brain replays emotionally significant events from the day during REM sleep, processing them in an environment of reduced norepinephrine, a stress neurochemical, which allows the emotional charge of the memory to be partially stripped away. In PTSD, this process is disrupted. The replaying continues, but the emotional dampening doesn't happen. The memories stay activated, charged, raw, and that activation can surface as vocalization, a voice rehearsing what the mind cannot resolve. The content of sleep talk gives researchers only partial access to what the sleeping brain is actually doing. In the 2017 linguistic study, around 50% of recorded sleep talk episodes were entirely incomprehensible, mumbling, muffled by pillows, or reduced to non-verbal sounds. Of the comprehensible half, researchers found that negative speech, refusals, objections, denials, appeared far more frequently than in normal waking conversation. The word no was the single most common utterance. This pattern suggests that the material the sleeping brain chooses to vocalize, when it does vocalize, tends to be conflict-laden, drawn from the unresolved, the uncomfortable, the still contested. One of the enduring myths about sleep talking is that it reveals deep secrets, that the sleeping mind, stripped of its social defenses, will confess what it would never say awake. Neuroscientists are consistent in their dismissal of this idea. Sleep talking does not operate like a truth serum. The speech it produces is not drawn from a private vault of suppressed information. It is drawn from the same disorganized, emotionally heightened processing that characterizes sleep itself. What you say in your sleep is more likely to reflect what you were feeling anxious about before bed than what you are consciously hiding. The content is emotional residue, not confession. Despite its prevalence, sleep talking has been studied relatively little compared to other sleep phenomena. One of the reasons is methodological, because sleep talking occurs randomly and unpredictably. Capturing it requires either continuous recording over many nights or the kind of laboratory monitoring that itself can alter sleep behavior. Most people who talk in their sleep do so only occasionally, and most episodes are brief, lasting seconds rather than minutes. The science of somniloquy is therefore built on a smaller evidence base than the science of REM sleep or sleep apnea, and many of its mechanisms remain subjects of ongoing investigation rather than settled consensus. The brain regions most implicated in sleep talking overlap significantly with those active during normal waking speech. Neuroimaging studies comparing waking speech to sleep talking have found activity in Broca's area, in the supplementary motor area involved in speech planning, and in the motor cortex controlling the lips, tongue, and larynx. What is notably absent or reduced during sleep talking compared to waking speech is activity in the prefrontal cortex, the region associated with intentionality, self-monitoring, and the conscious decision to speak. The sleeping voice is, in a precise neurological sense, a voice without a deciding mind behind it. The machinery runs, but the driver has stepped away. Sleep-talking episodes are almost always entirely forgotten by the person who produces them. This is because the brain regions that encode episodic memory, particularly the hippocampus, are operating in a significantly reduced capacity during sleep. Without the hippocampus actively encoding what is being experienced, the experience leaves no trace. This is why sleep is largely amnesic. Dreams are forgotten within minutes of waking, unless deliberately reviewed. And sleep talk is forgotten even faster, because there is no waking awareness of it at all. The voice that spoke in the night was not accompanied by a self that could remember it had spoken. Sleep talking appears to be more common in males than females, though the difference is modest. Some studies suggest men sleep talk slightly more frequently, and that when they do, the content is somewhat more likely to be aggressive or confrontational in tone. These patterns may reflect differences in the emotional material that the sleeping brain is processing. shaped by the waking life experiences, stress patterns, and emotional regulation styles that differ across gender on average. But the difference is not large, and sleep talking remains a phenomenon distributed broadly across all demographics, ages, and backgrounds, without any population being clearly exempt. There is a related but distinct condition called hypnagogic speech, which occurs in the transitional state between wakefulness and sleep. The hypnagogic state, unlike sleep talking, which occurs once sleep has begun. Hypnagogic speech happens right at the threshold, often accompanied by hypnagogic hallucinations. Brief, vivid sensory experiences that feel neither fully dreamed nor fully woken. People in the hypnagogic state may speak a few words or phrases that feel connected to a visual or narrative fragment they were experiencing. The speech is typically quiet, brief, and confusing to anyone who hears it. It represents the brain narrating a story that is just beginning to form in the gap between two states. Some researchers have studied whether it is possible to communicate with sleep talkers, to ask them questions during an episode and receive meaningful answers. The results are mixed. In some cases, particularly during lighter NREM stages, sleep talkers have responded to questions with answers that seemed contextually relevant, but the responses tend to be fragmentary, inconsistent, and often disconnected from the waking relationship between the speaker and the listener. A landmark 2024 study explored real-time dialogue during lucid dreaming. And while that work focused on REM rather than somniloquy specifically, it has reinvigorated interest in whether the sleeping voice can serve as a window into sleeping cognition more broadly. The brain's language system is remarkably robust even in degraded states of consciousness. Patients under general anesthesia, who are, by definition, not conscious, occasionally produce speech or speech-like sounds. People in minimally conscious states sometimes vocalize, and sleeping people, in the particular state of dissociation that produces somniloquy, speak words and sentences that follow the rules they learned over a lifetime. This robustness suggests that language, as a neural capacity, is deeply embedded, so deeply that it continues to operate at levels of consciousness far below what we typically think of as required for speech. The voice is one of the last things the brain lets go. PTSD-related sleep talking is sometimes distinguished by a specific quality. The sleeper appears to be reliving or rehearsing a specific scenario, rather than engaging in generalized emotional processing. The speech can be repetitive across multiple nights. Similar phrases, similar emotional tone, similar content. This repetition reflects the stuck-loop quality of PTSD memory processing, more broadly the hippocampus and amygdala, returning to the same material again and again. Unable to complete the arc of consolidation that would allow the memory to be filed and quieted, the sleep talk becomes a kind of acoustic trace of a memory that the brain hasn't yet found a way to put down. After 25 facts about somniloquy, a pattern has already begun to emerge. One that quietly reframes the original question. The brain that speaks without your permission is not malfunctioning. It is doing what it was built to do, processing, resolving, arguing, and negotiating, just without the overhead of waking self-awareness. What started as a question about an embarrassing quirk turns out to be a question about the nature of the voice itself. Is the speaking mind the one that chooses words, or is it simply the one that hears them? That distinction between the generator of speech and its witness is where the next arc begins. The night is not empty. It is working. Notice the weight of your body right now. The places where you make contact with whatever is beneath you. There is no conversation happening that requires you to be present for it. The part of your mind that forms words is resting now. Or trying to. Let it try. Let the sounds around you become texture rather than meaning. There is nothing you need to parse right now. No sentence to decode. No name to remember in the morning. Breathe once. Slowly. The voice that runs without you has said enough for now. You are not needed here. Let it quiet. Let yourself follow. Sleep talking tends to be more frequent during periods of increased cognitive load, when the waking brain has been processing a higher than usual volume of complex, emotionally significant, or socially demanding information. Research on sleep and memory consolidation suggests that the brain prioritizes certain categories of content for overnight processing events with strong emotional valence. Unresolved social conflicts, scenarios involving anticipated or feared outcomes. When the workload in these categories is high, the overnight processing is more active, and the likelihood that some of it surfaces as vocalization increases. Sleep talking is, in this sense, a byproduct of thoroughness. The brain doing its job very hard. The relationship between sleep talking and dreaming is more complex than commonly assumed. Popular belief holds that sleep talking reflects dream content, that whatever the sleeper is saying corresponds to what they are dreaming about. But the evidence is inconsistent. Studies that have woken sleep talkers immediately after an episode and asked them to report their dream content have found that the match is unreliable. Some episodes clearly correspond to identifiable dream scenarios. Others do not. And a significant portion of sleep talking occurs during NREM sleep, particularly stages 1 and 2, when dreaming, in the vivid narrative sense, is less common. Sleep talking and dreaming appear to be produced by overlapping but not identical systems. The thalamus plays a central regulatory role in both sleep and waking consciousness, and its behavior during sleep is crucial to understanding somniloquy. During wakefulness, the thalamus acts as a relay station, passing sensory information from the outside world to the cortex, and allowing the cortex's output to flow outward into action and speech. As sleep deepens, the thalamus progressively gates this relay, reducing both incoming and outgoing signal flow. During lighter stages of NREM sleep, and in brains prone to state dissociation, the thalamic gate partially reopens, briefly allowing the cortical circuits for speech to activate. The thalamus, when imprecise, gives language a momentary passageway back. There is evidence that sleep-talking content is emotionally consistent with the emotional state the person was in before falling asleep. Participants in studies who reported going to bed in a state of interpersonal conflict or social tension showed significantly higher rates of negative, confrontational speech content during sleep-talking episodes recorded that night. This is consistent with the broader model of sleep as an emotional processing engine. The brain begins the night working on what it was handed. If what it was handed was conflict, the processing will involve conflict. The voice that argues in the night is, in a very real sense, still working through the argument that didn't finish before the lights went out. The duration of most sleep-talking episodes is brief, typically between 2 and 30 seconds. But some individuals produce much longer episodes, including what have been called sleep monologues extended. internally coherent. One-sided speeches that can last several minutes. Sleep monologues tend to follow logical progressions, use appropriate vocabulary, and maintain a consistent emotional register throughout. They suggest that in certain states of sleep, the brain can sustain an entire line of reasoning or narrative without surfacing toward wakefulness. The person doing it has no idea. They will wake up having no memory of the speech and will find it difficult to believe, when told, that they produced something so structured. Sleep apnea, a condition in which the airway partially or fully collapses during sleep, causing repeated brief awakenings, is associated with elevated rates of sleep talking. The mechanism is partly straightforward. The micro-arousals produced by sleep apnea events create exactly the transitional, partially awake states in which sleep talking is most likely to occur. Sleep apnea also causes chronic sleep fragmentation, which over time disrupts the normal architecture of sleep stages and increases the overall instability of state boundaries. In a brain that never reaches fully consolidated sleep, the boundary between waking and sleeping speech becomes chronically blurred, and the voice finds more opportunities to slip through. There is a quality to the grammar of sleep talk that linguists have found striking. In the 2017 study of nearly 900 episodes, the researchers found that sleep talkers reliably produced correct subject-verb agreement, appropriate use of negation, and proper syntactic structure, even when the semantic content was unclear or nonsensical. This means the sleeping brain was applying the rules of grammar correctly, without any access to the intended meaning of the sentence. Grammar, it appears, is procedural, automated in a way that persists into sleep. The brain can produce grammatically correct language the way it can produce rhythmic breathing as a background process, running without supervision. One of the less discussed aspects of sleep talking is the experience of the person who hears it. For the person producing the speech, the episode is invisible and amnesic. For the person hearing it, the bed partner, the roommate, the parent in the next room, it can be unsettling in a way that is hard to explain. A familiar voice producing words without context, without acknowledgement, without the social scaffolding that normally makes speech interpretable. It occupies an uncanny register. The boundary dissolution that produces somniloquy is experienced not only neurologically by the sleeper, but socially by the listener. It makes the familiar strange. The prosody of sleep talk, its rhythm, intonation, and stress patterns, tends to be preserved even when the semantic content is absent or unclear. Recordings of sleep talkers show that question intonation rises at the end of apparent questions. That emphasis falls where emphasis would normally fall. And that emotional stress is audible in the vocal tone, even when the words themselves are incomprehensible. This means the sleeping brain is generating not just the linguistic content of speech, but also its musical shape, the layer of meaning that rides above the words and signals how the words are meant to feel. The emotional shape of language outlasts its content. Some neurological conditions that affect the regulation of sleep-wake transitions, including narcolepsy, which involves a dysregulated loss of the neurotransmitter orexin, are associated with unusual patterns of sleep talking. In narcolepsy, the boundary between waking and sleeping states breaks down in ways that can include sudden transitions into REM sleep from wakefulness, cataplexy, triggered by emotion, and various forms of parasomnia, including hypnagogic hallucinations and sleep paralysis. Sleep talking in narcolepsy can occur at unusual times, sometimes in social situations, as the person briefly slides into a dissociated state. The voice continues to speak across a threshold the person didn't know they had crossed. Certain medications, particularly those acting on the central nervous system, including some antidepressants, sedative hypnotics, and beta blockers, can increase the frequency of sleep talking as a side effect. Antidepressants in the SSRI and SNRI classes can suppress or alter REM sleep architecture, sometimes producing REM rebound effects that increase parasomnia activity. Sedative hypnotic medications, including some sleep aids, can produce a state of sedation that is not the same as natural sleep. And in this artificially altered state, the normal suppression of speech production may be incomplete. Medications don't create the tendency toward sleep talking, but they can lower the threshold at which it expresses itself. The question of whether sleep talkers are aware of their own speech in the moment of producing it is consistently answered in the negative. And yet the answer is more nuanced than it first appears. Awareness, in sleep science, is not binary. There are gradations of self-monitoring, from fully conscious speech with complete meta-awareness to purely automatic vocalization with none. Sleep talking occupies a position closer to the automatic end. The sleeper is not monitoring their speech, not choosing words, not evaluating the output. But this does not necessarily mean that the speech is entirely disconnected from the cognitive process producing it. Something is still selecting these words, in this order, in this tone. It simply isn't doing so consciously. Sleep maintenance, insomnia, the kind in which people fall asleep without difficulty but wake repeatedly throughout the night, is associated with elevated sleep-talking frequency. The repeated awakenings create multiple opportunities for the transitional states in which sleep-talking occurs. More significantly, the anxiety and rumination that accompanies sleep maintenance insomnia, the cycle of waking up, worrying about being awake, trying to return to sleep, provides a steady supply of activated emotional content for the sleeping brain to process. The architecture of the night becomes fragmented, and the voice follows the fragmentation, surfacing each time the brain passes through the threshold zone. The neuroscience of default mode network activity during sleep is relevant to understanding why sleep talking so often involves social and interpersonal content. The default mode network, or DMN, including the medial prefrontal cortex, the posterior cingulate, and the angular gyrus, is most active during internally directed thought self-reflection, social reasoning, and simulating future scenarios. During lighter NREM and REM sleep, certain DMN nodes remain active. This continued activity contributes to the social narrative quality of dreams. And when sleep talking occurs in these phases, the content tends to reflect the DMN's domain, other people, relationships, unfinished negotiations, and conflicts that never found a clean conclusion. A phenomenon that intersects with sleep talking but is distinct from it is called sleep-related groaning, or catathrenia. In catathrenia, the sleeper produces a long, sustained groan or moan during exhalation, typically during REM sleep, without producing recognizable words. Catathrenia is distinct from snoring in its respiratory mechanism and from sleep talking in its lack of linguistic content. It was classified as a sleep-related breathing disorder for many years. But more recent research has suggested it may be better understood as an expiratory parasomnia, a category of its own. its cause remains incompletely understood, illustrating how many different things the sleeping voice can do without producing a single word. You're drifting well. If tonight has been useful, if something about why the sleeping brain keeps speaking feels a little less mysterious, consider subscribing to Sleepy Mind Science. Every video here follows one question about how the mind works in the dark. No ads. Just science and stillness. Stay with me. The sleeping brain's tendency to produce conflict-laden speech, more no than yes, more refusal than agreement, may reflect the emotional architecture of memory consolidation itself. Research on overnight emotional processing suggests that the brain does not simply replay the day's events during sleep. It selects, compresses, and recombines them, with particular attention to events that carry unresolved emotional tension. The processing involves reactivating the emotional memory trace, working through its associations, and gradually reducing its arousal charge. The vocal output that sometimes accompanies this process, argumentative, resistant, refusing, may be the acoustic signature of that emotional work in progress. The suppression of speech during sleep is maintained primarily through descending inhibition from the brainstem, a top-down signal that progressively quiets the motor circuits as sleep deepens. This inhibition targets not just the large muscle groups involved in walking or gesturing, but also the fine motor circuits that control the lips, tongue, soft palate, and larynx. When this inhibition is partial or disrupted, as in state dissociation, RBD, or certain medication effects, the speech circuits are among the first motor systems to reactivate, because they are among the most frequently used and therefore the most robustly wired. The sleeping voice breaks through not because it is uniquely powerful, but because it is uniquely practiced. Sleep talking in elderly populations deserves particular clinical attention because of its possible association with neurodegenerative processes. REM sleep behavior disorder has a mean onset in the late 50s and 60s, and research suggests it often begins years before the onset of Parkinson's disease or Lewy body dementia. Studies suggest that up to 80% of people diagnosed with RBD may eventually develop a synucleinopathy, a class of neurodegenerative disease characterized by abnormal protein deposits in the brain. New onset sleep talking or dramatic behavior during sleep in an older adult is worth discussing with a physician, not as a certain warning, but as a signal worth investigating. The sleeper who talks is, in a fundamental sense, not the same entity as the waker who will wake. The philosophical implications of this are quiet but persistent. Memory, intentionality, self-monitoring, and continuity of experience. The qualities that we typically use to define a coherent self are all profoundly altered during sleep. The voice that spoke in the night did not know it was you. It did not know anyone was listening. It did not know that its words would outlast the state that produced them, surviving in the memory of whoever was awake to hear. In the morning, you inherit what you said, but you were not, in any meaningful sense, there when you said it. Research into the prosodic characteristics of sleep talk has found that emotional tone is preserved with notable accuracy. Recordings analyzed for acoustic features, pitch, intensity, tempo, and voice quality show clear correlations between the emotional content of the speech and these measurable markers. A sleep talker producing what sounds like an argument shows elevated pitch and intensity. One producing what sounds like reassurance shows a softened tempo and warmer voice quality. The emotional channel, the layer of communication that runs beneath semantic content and conveys feeling, appears to be more robustly maintained during sleep than the semantic channel. Sleep talk feels more reliably than it means. The frequency of sleep talking across the lifespan follows a declining trajectory with notable exceptions. It peaks in early childhood, decreases through adolescence and into young adulthood, and reaches its lowest point in middle age. But it often increases again in late life, partly because of age-related changes in sleep architecture, partly because of the increasing prevalence of sleep-disrupting conditions, and partly because neurological changes can reduce the efficiency of inhibitory systems. The voice that goes quiet in the productive middle years sometimes comes back in older age, older in character, different in content, but emerging from the same ancient mechanism that let it speak in childhood. One of the more consistent findings in sleep talking research is that the prosodic features of sleep talk are sometimes more accurate predictors of emotional state than the semantic content. In other words, how someone sounds when they sleep talk tells you more about what they are experiencing emotionally than what they actually say. This is consistent with broader findings in psycholinguistics, suggesting that emotional information in speech is encoded more reliably in acoustic features than in words. We adjust our words more easily than we adjust our voices. And in sleep, where the mechanism that chooses words is running without a supervisor, the voice may be the most honest channel left. Sleep talking that co-occurs with physical movement, tossing, gesturing, sitting up, is generally considered a more clinically significant presentation than sleep talking alone. When motor behaviors accompany the speech, it suggests a broader failure of sleep stage containment, not just the specific leak in the speech suppression system. This combination is more characteristic of REM sleep behavior disorder, or NREM parasomnias like sleepwalking and sleep terrors, than of ordinary somniloquy. In most cases, straightforward sleep talking without associated movement is benign, self-limiting, and not a cause for concern. The exceptions, repeated, intense, or physically active, warrant attention. There is a small but intriguing body of research examining whether the words spoken during sleep can provide a window into the dreaming mind. Some of this work has involved waking subjects immediately after speech episodes and asking them to describe their mental state. In a subset of cases, particularly during REM episodes, subjects reported dream content that corresponded meaningfully to the words they had spoken. In others, they reported no dream at all, or dreams bearing no apparent relationship to the speech. The evidence is insufficient to draw strong conclusions, but it keeps open the possibility that sleep talk is sometimes a direct transcript, and sometimes something else entirely. Halfway through this journey, the picture of the sleeping voice has become more intricate than the question first suggested. What is the brain doing when it speaks words you never consciously chose? It is processing conflict. It is running grammar automatically. It is continuing conversations the day left unfinished. And occasionally, it may be narrating the dream. None of these answers is complete on its own. Each leaves something unresolved. Why these words and not others? Why this moment and not another? The second half follows what the first half uncovered, not what the voice says, but what it reveals about a mind that never fully stopped running. The night continues. So does the voice. You are past the halfway point now. Your breath is slower than when you began. The voice that speaks in sleep has been the subject of everything here. And somewhere in this room, as you listen, your own voice is resting, not performing, not choosing, just quiet. Let that quietness come in a little further. There is no word that needs to be said right now. No conversation left unfinished that cannot wait until morning. Let the part of your mind that produces language rest completely. Let the part that listens rest too. There is only this: the breath moving in and the breath moving out, steady and unhurried. You are safe here. Continue. The default mode network, that constellation of brain regions associated with self-referential thought, social simulation, and mental time travel, shows a complex pattern of activity during sleep. During NREM sleep, its connectivity decreases relative to wakefulness, reflecting the general reduction in integrated brain activity. But during REM sleep, certain nodes of the DMN reactivate, producing a pattern that partially resembles waking internally directed thought. This REM reactivation is thought to underlie the narrative, social, and emotionally charged quality of vivid dreams. And when sleep talking occurs during REM, the content often reflects the DMN's domain relationships, unresolved scenarios, social negotiations that never fully concluded. Sleepwalking and sleep talking share significant neurological overlap. Both are classified as NREM parasomnias. Both involve state dissociation, the same partial failure of stage boundary maintenance that allows waking behaviors to persist into sleep. Both are more common in children. Both have a heritable component. And both tend to cluster in the same individuals and families. But they involve different motor systems. Sleep talking recruits the speech production network, while sleepwalking recruits the circuits governing locomotion and navigation. When they occur together, as they do in some individuals, the result is a more comprehensive enactment of waking behavior, the brain acting out and narrating simultaneously. There is a version of the central question that reveals itself more clearly as the facts accumulate. When the brain speaks words you never consciously chose, it is not speaking randomly. It is speaking from something, from the material it has been given, the load it is carrying, the patterns built over a lifetime. The voice without a witness is not a malfunction. It is, in the most stripped-back sense, the mind thinking out loud in the absence of the self. What this implies about the relationship between speech and thought, whether they are the same process viewed from different angles, or genuinely separate, is a question neuroscience has not yet resolved. Research on bilingual sleep talkers offers an interesting angle on the automaticity of sleep talk. Studies have found that bilinguals tend to sleep talk in their first language, their mother tongue, more frequently than in their second, even if they are highly proficient in both and use the second language predominantly in daily life. The first language, acquired earliest and practiced longest, is more deeply embedded in the procedural memory systems that persist during sleep. This finding is consistent with broader evidence that the most automatic aspects of language, the earliest learned, most frequently used, most emotionally resonant, are the most sleep-resistant. The mother tongue is the last thing the sleeping brain gives up. The body's autonomic responses during sleep-talking episodes suggest that the brain is not simply running idle language processes. Heart rate measurements taken during documented sleep-talking episodes show modest but measurable increases relative to baseline sleep, consistent with mild emotional activation. This activation is not as large as that seen during nightmares or sleep terrors, but it is above resting levels, suggesting that whatever cognitive process is producing, the speech carries some emotional weight. The sleeping body is not indifferent to what the sleeping voice is saying. It registers the material, even without being awake to interpret it. Some of the most narratively complete sleep talk episodes reported in the research literature bear a resemblance to what psychologists call inner speech, the internal monologue that runs through waking consciousness. Inner speech is not simply speech directed inward. It is condensed, predictive, and elliptical. The brain communicating with itself using a private shorthand that relies on context only the speaker possesses. Sleep talking that resembles inner speech. Incomplete sentences. Implied reference. Self-addressing pronouns may represent the outer leakage of a process that is usually entirely internal. The brain talking to itself, but loud enough for someone else to hear. There is a small body of research examining sleep talking in the context of trauma processing and what has been called the continuity hypothesis of dreaming. The idea that dream content tends to reflect the preoccupations of waking life. Under this hypothesis, sleep talking that occurs during processing of emotionally significant events would be expected to reflect the emotional texture of those events, not necessarily their literal content, but their affective register. This prediction is broadly supported by what researchers have observed. Sleep talk tends to match the emotional temperature of the preceding day, even when the words themselves are entirely uninterpretable to anyone listening. The experience of hearing someone else talk in their sleep is, in a precise sense, an encounter with a person who is not quite there. The voice is familiar. The words are in the right language. The prosody carries the right emotions. But the social contract, the mutual awareness that underlies normal conversation, is absent. No one is listening to you. No one is waiting for your response. The voice is broadcasting, not communicating. This one-way quality is what makes hearing someone sleep talk feel uncanny rather than simply strange. You are receiving a transmission from a mind that has no idea it is transmitting. Brain imaging studies conducted during naturally occurring NREM sleep have found evidence of what researchers call local sleep, the phenomenon in which some brain regions enter a sleep-like state while others remain active. Local sleep has been documented in animals first, then confirmed in humans, and it fundamentally challenges the idea of sleep as a global, uniform state. Under the local sleep framework, sleep talking is not anomalous. It is what local sleep predicts. The language areas in a partially active state while surrounding regions have descended. The voice is the output of a region that hasn't fully joined the rest of the brain in going quiet. A detail worth holding the word that sleeping brains most often produce, no, is also one of the first words that human children learn to say, before requests, before descriptions, before names. Refusal, the capacity to mark a boundary with sound. Sleep keeps returning to this oldest of words. The sleeping brain, given language and no editor, turns toward the most deeply rooted utterance it carries. And in that refusal, quietly repeated in the dark, there is something that has been with the voice since the very beginning. The first assertion of a self that existed and had needs and knew the difference. Sleep talking can be induced experimentally in laboratory settings, though not reliably. Researchers have attempted to trigger episodes by administering mild auditory stimuli during NREM sleep, playing soft sounds or words, and observing whether the sleeping brain incorporates the stimulus and produces a response. In some subjects, this works. The sleeping brain processes the incoming sound, identifies it as language, and generates a response, sometimes directly referencing the words spoken, sometimes producing an associated phrase. The finding supports the idea that the sleeping brain retains some capacity for environmental monitoring, even in states where consciousness appears to be absent. The relationship between sleep talking and memory consolidation has been explored through studies of targeted memory reactivation, a technique in which specific sounds or smells are paired with learning tasks during wakefulness, then represented during sleep to strengthen associated memories. While this technique was developed for other purposes, its success has raised an intriguing implication. If the sleeping brain can be cued to reprocess specific memories through sensory triggers, then sleep talk might sometimes reflect exactly that kind of reactivation. The brain working through a specific memory, triggered by an association, producing the verbal residue of a trace being reinforced. There is a quality in the studies of sleep talking, in their careful methodology and honest acknowledgement of what remains unknown, that mirrors the thing they are studying. Sleep talking is a phenomenon that reveals more about what the mind cannot fully access than about what it knows. The science of it is similarly incomplete, thorough in some places, uncertain in others, and aware of its own limits in a way that makes it trustworthy. The voice in the night is not a solved problem. It is a well-described one, and in science, that is a respectable place to stand. Some individuals who sleep talk frequently report, on waking, a vague sense of having been unusually active during the night, a sense of mental fatigue that doesn't correspond to the hours slept. This subjective experience may reflect genuine increased neural activity during sleep, or it may simply reflect the disrupted sleep continuity that often accompanies frequent parasomnia episodes. Either way, it points toward the cost side of somniloquy. Even if the brain is doing useful work during these episodes, the doing of that work consumes resources and can leave the waking person slightly depleted in ways they cannot fully account for. The content of sleep talk, when intelligible, tends to fall into a small number of recurring categories: argument, instruction, emotional expression, and social negotiation. Questions appear less commonly than statements. Requests appear less commonly than objections. The pattern suggests that whatever material the sleeping brain selects for vocal processing, it is more likely to involve assertion, resistance, and conflict than curiosity, cooperation, or shared understanding. The sleeping voice is, en balance, defensive, a guard still walking the perimeter of a house whose occupant has gone to bed. Recent theoretical work in sleep neuroscience has begun exploring sleep as an active, generative process rather than a passive withdrawal. Under this framework, associated in part with Giulio Tononi and colleagues, whose 2024 review in the journal Neuron examined the relationship between sleep and consciousness. The brain during sleep is not merely conserving energy or replaying data, it is solving, integrating, and preparing. Sleep is when the brain builds the connections that waking experience provides the raw material for. Sleep talking, in this view, is the audible edge of a system that is profoundly active. The brain waves associated with sleep-talking episodes have been examined in polysomnographic studies. Recordings that capture EEG activity, eye movements, and muscle tone simultaneously. In NREM sleep-talking, researchers often find K-complexes, large amplitude slow waves, immediately preceding or accompanying the episode. K-complexes are thought to represent the brain's response to external or internal stimuli during sleep, possibly serving an inhibitory function, dampening arousal responses to protect sleep continuity. When K-complexes accompany speech, it suggests that the speech event is being simultaneously produced and suppressed, the brain generating the vocalization while also trying to contain it. Sleep talking in children is most commonly benign and resolves on its own as the nervous system matures. Parents who observe their children talking in their sleep should be reassured that in the absence of signs of distress, screaming, violent movement, confusion upon waking, or daytime symptoms, it is not a condition requiring intervention. The childhood brain is simply doing what childhood brains do, learning to manage the boundary between waking and sleeping in a nervous system that hasn't yet had decades to practice. The voice in a child's room at 2 in the morning is usually just a brain rehearsing a skill it will eventually stop needing to rehearse so loudly. The same circuits involved in inner speech, the silent, self-directed language that accompanies much of human thought, are the circuits that produce sleep talk. Inner speech is generated primarily in Broca's area and the pre-supplementary motor area, with modulation from the prefrontal cortex and anterior insula. Sleep talk appears to recruit the same regions, but without the prefrontal modulation, this absence of prefrontal oversight means the voice that speaks in sleep is thought without editing, the raw output of the language generation system, unfiltered by the mechanism that normally decides whether an internal word should become an external one. There is a philosophical framework in which sleep talking acquires particular meaning. In phenomenology, the study of first-person experience, consciousness is described as always directed toward something. It is intentional in the technical sense of having an object. Waking speech is the conscious mind directing language toward a listener or a world. Sleep talk is language without that directedness. Speech with no listener in mind. No world it is trying to reach. No self choosing to send it. It is language as pure process, unmoored from the intentions that give speech its purpose. And yet it follows all the rules. The architecture holds even when the meaning is gone. The physiological conditions that make sleep talking more likely: state dissociation, partial inhibition failure, emotionally elevated sleep content, are also the conditions that make other sleep phenomena more likely: vivid dreaming, hypnagogic imagery, sleep paralysis, and various forms of micro-awakening. This clustering suggests that some brains simply live closer to the waking-sleeping boundary than others. They occupy the threshold more often, for longer periods. With less complete commitment to either side, these brains generate more material at the boundary, more dreams, more imagery, more speech. They are not disordered. They are, in many cases, highly active. The cultural history of sleep talking is older than its scientific study. Across many traditions, The words spoken in sleep have been interpreted as communications from other realms, divine messages, prophetic utterances, or the speech of a soul temporarily freed from the waking body's constraints. These interpretations reflect a genuine intuition that the voice in sleep is coming from somewhere other than ordinary waking consciousness. Science has replaced the supernatural interpretation with a neurological one, but the underlying intuition that the sleeping voice is coming from a different part of the mind is not entirely wrong. Contemporary sleep research has increasingly emphasized that sleep consolidates not just explicit memory, the kind you can report and describe, but also implicit, procedural, and emotional memory. This expanded view situates somniloquy within a larger story. The brain is not just filing facts during the night. It is reorganizing the emotional architecture of experience, renegotiating the weight of what happened, updating the internal model of the self and the world. Sleep talking is one of the surface expressions of this deep work. The voice that objects and refuses in the night is the sound of a mind taking its own experience seriously. The quieting of the prefrontal cortex during sleep, and its associated systems of self-surveillance, creates what researchers describe as a condition of reduced top-down control. The brain's capacity to censor, evaluate, and redirect its own output is diminished. The content that surfaces in sleep, in dreams, in sleep talk, in the emotional residue of the night, bypasses the filter. It is less shaped by social expectation, less curated by self-presentation. Sleep talk is not honest in the sense of being true, but it is unedited in a way that waking speech rarely is. The voice loses its editor before it loses its grammar. After 75 facts, the answer to the central question has taken shape. What is your brain actually doing when it speaks words you never consciously chose? It is processing what it was given. It is applying rules so deeply learned they no longer need deciding. It is doing the emotional work the day produced and the waking self couldn't finish. And it is doing all of this in the one channel that remained open. The one so deeply practiced that it persists even as consciousness withdraws. The voice you lose control of at night is your brain's unedited inner life, still working through what the day left unfinished. What follows now is less explanation, more feeling. Let it carry you. Your body has been here the whole time, resting. The voice that was the subject of every fact tonight, the one that speaks without permission, that follows grammar it no longer remembers learning. That voice is quiet now, or nearly quiet. Let it go the rest of the way. There is nothing left for it to process. The day's unfinished conversations have been handed off to the part of you that works without words. You don't need to speak. You don't need to follow. Just breathe. And let the brain do what it does in the dark, quietly, without you, exactly as it was built to do. Rest into that. Let go. The sleeping voice does not know it is being heard. It speaks into a room that may be empty, into a silence that may be complete. It chooses nothing about the moment of its speaking, and still, it speaks. Still, it follows the rules of the language it was taught. Still, it carries the weight of what it was given. There is something in that, a faithfulness without intention, a continuity that doesn't require a witness to be real. Language learned earliest stays longest. The first words a brain ever acquired, in whatever language they were, sit in the deepest layers. They are the words that remain when everything easier to access has gone quiet. The mother tongue is a root system, and roots do not sleep the way the canopy does. They stay, quiet and reaching, all the way down. The word no is among the oldest things the human voice learns to make. Before requests, before descriptions, before names. Refusal, the capacity to mark a boundary with sound. Sleep keeps returning to this. The sleeping brain, given language and no editor, turns toward the oldest word it knows. And in doing so, it keeps practicing the most fundamental act of selfhood, the assertion that there is a self here, and it has a position. A grammar that runs without a speaker is still a grammar. The rules of syntax persist in sleep not because anyone is following them, but because they were learned so completely they became structure, like the architecture of a house that stands without anyone inside. The walls hold the shape of the rooms even when the rooms are empty. Language holds its own form even when the mind that built it has gone to rest. The thalamus closes and opens through the night. It regulates the flow between the outside world and the inside mind, slowly shutting the door as sleep deepens, occasionally letting a draft through. Speech is one of the things that gets through a door left slightly ajar, not because it forces its way, but because the opening was already there, and the voice was already practiced enough to find it. Some brains live closer to the threshold. They do not settle as far into either state as others do. They occupy the edge more often, the place where sleep and waking share a wall, and sometimes exchange something through it. These brains dream more vividly. They speak more in their sleep. They carry the boundary inside them like a coastline, always slightly in motion. A conflict left unfinished at 9 in the evening is often still running at 2 in the morning. The brain does not require the waking self's permission to continue. It takes the unresolved and returns to it quietly, without announcement, without conclusion, turning it over, wearing it smooth, releasing a little of the charge each time it passes through. The night is long enough. Most things soften by morning. The voice does not need to be heard to have done something. The processing that produces sleep talk is not aimed at a listener. It is internal work, externalized by accident. Whether anyone hears it is incidental. The work was already happening. The voice was already doing what voices do. It simply forgot, for a moment, that no one was there to receive it. Emotion travels through the voice faster than it travels through words. The prosody, the musical layer, the rise and fall, carries feeling with a fidelity that meaning alone cannot match. In sleep, the words may be gone, but the tone remains. You can hear someone's sadness in their sleeping voice, even when you cannot understand what they are saying. The feeling comes through cleanest when the editing is gone. The sleeping brain is not absent. It is occupied differently. It is attending to a different order of things. The slow work of consolidation, the processing of what mattered, the quiet rebuilding of what tomorrow will require. It is not resting from thinking. It is thinking in a register that does not admit the waking self. Children's voices in sleep carry the sound of a brain still learning where the edges are. The transition between states is less practiced, more leaky. The voice escapes because the container hasn't fully formed yet. As the years pass, the container becomes more precise. The leaking slows. But what the leaking was, that is still there, deeper and quieter, still doing the same work in the dark. There is something precise about the way grammar persists into sleep. Subject agrees with verb. Negation falls in the right place. Structure holds even when meaning fails. The brain follows rules it no longer remembers learning. Which is what mastery looks like, the thing that no longer needs attention in order to be done correctly. Every time, even in the deepest dark. The face of the person sleeping beside you. The sound of a name spoken in the dark. These are among the things that can find their way through the thalamic gate. The sleeping brain has a filter, not a wall. Familiar things pass through more easily than unfamiliar ones. Love, in this sense, is acoustically persistent. It crosses the threshold even when the self has withdrawn from the threshold entirely. Stress is loud in the sleeping brain even when the waking brain has quieted it. The cortisol that accumulated during the day does not disappear at bedtime. It enters sleep with you. The brain, encountering it, begins the long work of metabolizing it, converting the charge of the day into something the body can eventually set down. Sleep talking can be the sound of that conversion in progress. The voice that speaks in sleep is not lying and not telling the truth. It is doing something prior to both of those things, generating language from whatever is currently most active, without the capacity to choose, to conceal, or to select for effect. It is the voice as process, stripped of its purposes, still running, still following the form it was taught. There is a gentleness in not remembering. The episodes pass without trace in the person who produced them. No embarrassment from the words said. No record kept. The morning arrives clean, or nearly clean. The voice spoke its piece in the night and left nothing behind for the waker to answer for. There is, in that structure, something almost kind. The deepest stages of sleep are mostly silent. In stage 3 NREM, slow wave sleep, the brain is generating large, synchronized delta waves. The cortex is at its most quiescent, and the conditions for speech production are at their least favorable. The silence of deep sleep is not nothing. It is the brain doing the work that requires the most energy and the fewest interruptions. A voice that surfaces in sleep has usually been carrying something since before the day was over. The material is not new. It was there at dinner, or at the meeting, or on the commute. Sleep simply gives it the space to continue without interference. The night is not when the carrying begins. It is when the carrying can finally be heard. The boundary between sleeping and waking is not a line. It is a region, a territory with its own properties, its own phenomena, its own rules. Sleep talking lives in that region. So do hypnagogic images, and the sensation of falling, and the sound of a name that seemed to come from just outside the window. The boundary is inhabited. Things happen there. The brain that argues in the night is the same brain that will wake up tomorrow and try again. It is not separate from the waking self. It is continuous with it, carrying the same history, the same language, the same unfinished things. What the sleeping voice was working through, the waking person will continue working through, by different means, in different light. Sleep is not an interruption of consciousness. It is another form of it, one that processes what the waking form could not, that does the work that wakefulness generates but cannot complete, that keeps the architecture of the self intact across the dark hours. The voice in sleep is part of that maintenance, a sound from inside the ongoing project of being this particular mind. Something small and persistent about the sleeping voice, it almost always follows the grammar of the waking voice. After all, the other rules dissolve. The social ones, the editorial ones, the ones about what is appropriate, the grammatical ones remain, as if the structure of language is the last thing the mind releases, as if the form of human communication is so deep that even sleep cannot reach the bottom of it. The voice carries through the night, even when nothing coherent is said, even when what is said is only a refusal, only a fragment, only a sound shaped like a word. The speech apparatus stays ready. The circuits stay practiced. The night is long, and the brain remains, quietly, in the business of being a speaking thing, ready, always, for the next word. What is heard in the sleep of someone you love is not a secret. It is something less structured than that, and more intimate. It is the sound of a mind that has laid down its composure and is simply continuing, working, breathing and speaking and carrying and releasing. In the dark, without an audience, without a purpose it has chosen. It is the unguarded sound of another consciousness, passing through the night. The answer is not that the brain never stops. The answer is quieter. The voice that speaks in sleep is not a departure from who you are. It is a layer of who you are that rarely gets to surface. The unedited, unmonitored, grammatically intact, emotionally honest voice that keeps speaking after the decision to speak has gone to sleep. What you say in the night is not a confession. It is simply what continues. And what continues in the dark, without an editor, without an audience, is closer to the truth of the mind than almost anything the waking self will say tomorrow. Something was already speaking before you fell asleep tonight. We followed it from the threshold, that moment of partial wakefulness, where language persists because it is too deeply learned to fully stop. Through the grammar that runs without a speaker, through the word no that sits at the root of human speech, through the emotional charge that travels in prosody long after meaning has gone quiet. What began as a question about an embarrassing quirk turned out to be a question about the architecture of voice itself. The brain doesn't speak in sleep because something has gone wrong. It speaks because speaking is what it does, deeply enough, automatically enough, that even sleep cannot fully take it away. The voice was never just yours to control. It belonged to the mechanism long before it belonged to the self. The series called Relaxing Facts About Sleep to Fall Asleep To has been tracing the sleeping mind across many hours. The next hour follows not the voice that speaks in sleep, but the silence surrounding it. And what the brain does there, that hour is waiting whenever you are ready. Something in you is already releasing, the way a conversation finally runs out of things it needed to say. Let your breath slow to the pace that belongs to the dark. The voice that was working through the night has said what it needed to say. You don't need to say anything now. You don't need to finish anything. If sleep comes, let it carry you to the place where the language circuits finally rest, where even the deepest grammar goes quiet, and there is only the slow tide of breath and the dark that holds it. But if your eyes are closed, stay there. Rest well. Quiet mind. The voice you couldn't hear tonight was doing something true, where the sleeping mind is never alone. Good night.